All right, so we're going to go ahead and finish up part 4 at long last. Okay, so this is as far as we need to go with notes. Next up, I'd like for you to try the check for understanding. And then when you're ready to go through it, go ahead and continue this video. Otherwise, please pause, do some learning, see what you can do. And then, when you're ready, I'll walk through it. All right, so got a situation up here. Westville High School. There's some juniors, there's some seniors. Some of them have parking passes. We're doing a sample of 30 seniors and 30 juniors, and we're looking to find the difference of sample proportions of seniors and juniors that has parking passes. Okay, first of all, we have to figure out what is the shape. Hopefully it's approximately normal, otherwise we can't really do anything, but we have to show that it is. So to do that, we're going to check and show that the large counts condition is met for both populations. So let's look at our juniors first of all. For our juniors, we have a sample of 30, and 0.65 of them have a parking pass. That would give us an expected value of 19.5, which is greater than or equal to 10. We also have to check the juniors who don't have parking passes. That would be 0.35, which would give us an expected value of 10.5, also greater than or equal to 10. We have to do the same thing for seniors. So we have a sample of 30. Our 42% of them have parking passes. So that's going to give me 12.6 for an expected value, which is more than 10. Yay. And then we also have 30 times 0.58, and that's equal to 17.4, which is also greater than or equal to 10. Therefore, because all 4 of those expected values are larger than 10, we can state that the shape of the sampling distribution will be approximately normal. All right, next up, we're finding the mean of the sampling distribution. So looking back at our notes, that is this part. All I need to do is subtract the population proportions. Because we're doing seniors minus juniors, I have to make sure to do that in the right order. Oh, it looks like I said the wrong thing. These were our seniors, right? And these were our juniors. That stands for simple random sample. I'll just write it out. Seniors and juniors. It's all good though. Okay, so for this, it's going to be 0.65 minus 0.42, which gives me 0.23. That's the mean of my sampling distribution of the differences. Okay, C is asking for us to calculate and interpret the standard deviation of the sampling distribution. So this is going to be this formula, which looks like a lot, but it's not horrible. So we'll do it. It'll be okay. I don't have a ton of space for it, but that's all right. All right, so it's going to be 0.65 times 0.35 all over 30 plus 0.42 times 0.58, also all over 30, because both of the samples were of 30. Square root of that whole thing gives you 0.125. For interpreting, I can say the difference in sample proportions who have a parking pass and then you know I'm going to use those words, typically varies by about 0.1253 from the true difference in proportions. I know that just seems like a lot. It seems like wordy. It might be a little confusing. The more we practice it, I think it'll start to flow a little bit more. All right, so this last question is asking us for a probability. We know we're looking at a normal distribution. So I need a new slide. I can't do it. Don't want to fit it in that tiny spot. All right. So this is for question 4 on the check for understanding. All right, so looking for the probability, I'm just going to go ahead and label my curve. I know the mean is 0.23. And just going to label everything else properly. So mean, comma, standard deviation. And then let's see what we're looking for. What is the probability that the difference is greater than 30%? So 30% is here. We're looking for what is the probability that we're looking at something greater than 30%. Using normal CDF is the easiest way to solve here. And if you're using normal CDF to explain your work, just make sure that you are saying what your numbers are. So my lower is 0.3, upper, random huge number, mean 0.23, standard deviation is 0.125. So grab your calculator if you haven't yet. Normal CDF, gonna plug all this stuff in. And I'm getting a probability of 28.78 or 0.77%. All right, we finished our Google Doc, guys. The other thing you have to do for this week is Unit 5, Part A on College Board.